Now I'll start with the measurement. So when I press measure, a small twitch should occur. Maybe it won't because it's the current is really low, but let us try. Something happened. I could see it from here. I don't know if you could see it from there. So that's the first response. So this orange curve is always the current response that I get. So these numbers here now are not relevant because I'm just stimulating a very, very small portion of the muscle. So I'll go to 20 milliamperes now, around 20. You don't have to be very precise. Usually I don't even look at the scale. I just go up, up, up until I get the response. Okay, let's measure again. Now we have a good response already. So that was the first measurement. This is the second one. I'll go to 30. Measure again. So you can see that this is now increasing. So usually what I do is I'll keep for now maybe one or two more. Okay, let's go to 40. Measure again. So you can it's still increasing. What I'll do now is just to get the clear idea, I'll just focus on last and second to last, because this is what I'm interested in during the measurement protocol. I want to see two exactly the same responses, one after another, okay? So I'll go to 50, measure again. Now you can see it's almost no difference between 40 and 50. So what you're looking at, you don't want to see any changes up to here. If you will see some changes later on, these are those parameters that we already discussed, the relaxation time, sustain time. They are not so very stable, and also they're not so very important. So what I'm looking for, I want to see up to maximum response. I want to see stable.
So could you just explain why you don't want to see a change?
Because if there is a change, that means that I still haven't reached the maximum response, and I want to get the maximum. Okay, let's try one more. So I increased it by the next step. I went to 55 now, and there is no change. So 40, 50, 55, all the same responses. So I have all the measurements here. The last one is always on top, so it's piling up. So it says graph 0. That's the orange one that I have here. And now I can look at the results, actually. So what I see here, in this case, it says, okay, this muscle here, it's 20% faster than the average because the reference value is 28. His value is below 23. So this muscle is much faster than the average, which is good. And then when I look at displacement, it is a slight difference, 8% than the normal or the average value, but it's within the normal range. So it's not too stiff, it's not too loose. So from that point of view, I would say good tonus, very good speed. Nice result. So I will keep the last measurement. I click Save Last here. And all the other measurements before with the lower amplitude are deleted, and I'm left with this. Why I'm deleting the previous ones? Because when I generate the report, the software will take the average of all the measurements that I have for that muscle. And if I take the one with 10, 20, I will just get the average of everything. So I'm interested in the last one. So I'm finished with this muscle. I move on to the next one. So like I said, I'll do the rectus femoris now. And I'll try to do it a bit quicker now so we don't lose too much time. Okay, extend again. What sport do you do?
Athletics.
Athletics?
Middle distance running.
Middle distance. Okay. Relax. Okay, I'll start with 20 now. So, okay, maybe I can try one more to be completely stable. That's it. So what you saw here probably was a little bit of kicking motion. You can see that here it doesn't influence any of the parameters. We stop monitoring here. So what happens later on, it does not influence the result. So you don't have to force the subject into complete still, because, like I said, you will probably, if you do that, you will even affect the results a little bit because you will prevent the movement. So again, 20% faster. So you're right on the mark. 20% faster than the average, and the tonus is, again, almost optimal. So good result here. So we'll just do one lateral symmetry, and then we'll turn him around and do the functional symmetry, so you will see. So when I change to the other leg, now this green curve, it's the same muscle on the other side. So we'll have immediate comparison between left and right. Okay. So what you can see here, there is a change, there is a difference in muscle tonus, but the speed is almost identical. So overall symmetry will be still fine, but the lateral symmetry from the displacement point of view will be just right on the edge. We'll see that when we generate the report. Now we'll switch to the right biceps femoris. Okay, so for the last three measurements, this first part was the same all the time. The second part continues to increase. That's the co-contraction from the semitendinosus muscles. So what I'll do is I'll just stick to the last measurement because it's very stable. I don't want to have the interference from the neighboring muscles. So I'm just saving this. Again, this muscle is quite fast. And when I finish, I click Generate the Report and choose which report I want to generate. And in this case, we'll go with the individual report. We'll just set you loose. Just stay here for a second, okay? So now the data we'll get will be a little bit limited, but what we have here is we measured 5 muscles. We only have one pair. We have vastus medialis left and right. So the contraction time is almost identical. It's 22 point something. There is a difference in displacement. So the overall symmetry is not very high. But if you just look at the overall symmetry of the contraction time, the speed of velocity, it's almost 100%. And the displacement symmetry is a little bit lower. Here at the end, we have the combined symmetry of all parameters. What the software does, in addition to that, but it's not displayed, it compares each parameter and looks for the differences. If the differences of one isolated parameter is bigger than this 20% from the contraction times and bigger than 30% for displacement, it will give out a warning. So in this case, the number is still okay. For the patellar ligament symmetry, in which the lateral and the medial quadriceps heads are combined, 91% symmetry is recorded, which is quite good, I would say. So we have 22 milliseconds here and 22 something here. So the symmetry is very good from that point of view. Knee symmetry, in which we compare the combined result of all three quadricep heads to the biceps femoris, again, it's 91. So as you can see here, that the range of these muscles for him is from 22 up to 25 milliseconds, which is very good. Usually you would see a variation which is much, much bigger. But okay, he's a runner. That's something that he needs to have if he wants to be a good runner. Let's look at this point of view. Of course, if you have just a few muscles, you don't see much. What you see here that all of the muscles, all four muscles that were measured are faster than the average, and all displacements are within the normal range. So when comparing to the reference values, his values are almost optimal. So when you look at the recommendations, what you'll get is you will just get the recommendations that one of the vastus medialis needs to be toned up a little bit, and one of the vastus medialis needs to be stretched or relaxed. This is because of the difference of displacement that was displayed. From the speed of contraction point of view, everything was perfect. So this is something that is then explained here. So it tells you, okay, you have the displacement difference which is bigger than it should be, so the one that is too stiff needs to be stretched, the one that is too loose needs to be toned up. So what the goal is to balance out these differences. But overall, I would say, yeah, quite a nice result. So this is what the measurement protocol looks like, and this is how fast you get the results.